Welcome, everybody. We are now going into Module 2 today. It is April 1st, 2024. But before we dive into Module 2, I am going to go through a couple different things. First, I want to talk about Lab 3 because there was one piece that we kind of omitted last time and we kind of ran out of time to take care of it. So I want to make clarity on that. And then I'm going to go through the solution for the mortgage calculator to show you how to complete that assignment. All right, so let's first take a look at Lab 3. When we were working on this last week, and I'm going to zoom in just ever so slightly here, maybe not so slightly, to take a look at what we were being asked to do. And when we coded this, we actually omitted this piece. And I don't know if you guys recall that. And this was kind of the conversation we were having before class started, because often, when we get loans, they tend to fall into two categories. One is like kind of like an asset-based loan, like you buy a car, a motorcycle, a house, or something like that. And the interest on those types of items is typically calculated on a monthly basis, and that's really what this question is. How many times is interest applied per year? 12 would imply that it's applied once per month, right? If I were to use unsecured credit like a credit card, or in some cases a line of credit, depending on your bank, they will accrue interest on a daily basis, right? And in which case the number you'd type in here would be 365, right? And that's kind of like one of the significant differences between those types of loans, and why you're better off in some cases, with like a home loan or, a second mortgage than you are with like a line of credit or a credit card. So we didn't have that piece in there. And what we had done in our code, and this is the Lab 3 solution here that you're seeing, is we had hard coded this piece in there. In other words, how many times per year it compounds was 12. And what I did in the aftermath, and I did it right before class started here, is if you wanted to keep it hard coded, you could just output that to the screen and just say number of times interest is applied per year, and whatever that hard coded number is, you could just output it to the screen, right? So that would kind of make it look like the example. Now, if you wanted to do it as an entry, where you're allowing the user to type that value in, then the program would get changed to this format where I'm actually doing an input prompt. They type in probably 12, because that's most typical for most, like I said, asset-based loans. We convert it to an integer, store it in compounds, and then we can use that to do our calculations down here. And if you look at the example amounts here, so I'm going to like use these amounts. So 10,000, 3.875, 12, etc. And you can see the values are already here. I already ran this before. So this is the output that you see down in the console, and you can see that it works, but that's without that prompt. So I'm going to run it again, and we'll do, click down here, 10,000. The interest rate was 3.875. Number of times it is applied per year is 12. And the number of years was 7.5. And then you can see how that dollar amount matches up with the example. And now the output here, in essence, is just like the output here. The only difference is I didn't put a blank line in here, but that's not a big deal, right? It's getting the mechanics of it to work correctly, getting the input, convert to numbers, to store it, have the right calculations and equations, and then show the output correctly. Those are the challenges there. Right. So that then would be the solution for Lab 3 with all the pieces in place. And then, if you need to kind of like, screen grab the whole thing, here it is, right? Hint, 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 right? I know you guys can go back and watch the video, but if you haven't figured that out yet, if I'm sharing my screen, you can screen grab it from there as well. All right, so that's Lab 3. You'll notice right now it's in unsaved mode because the circle is active, so I'm going to do a Control S to save. Now I do have the assignment, the mortgage calculator, already solved, and I have it here in this tab, but I'm going to actually build it from scratch. So I'm going to come over here and create a new file, and I'm just going to call it, let's see, what are we going to call it? Mod one assigned. That's probably adequate. .py. So here it is, blank. And then what I'm going to do here is I do have a solution here on my other screen, so I am kind of borrowing it from it. So the first thing I'm going to do is I'm just going to put in this comment here and say, hey, we need the input from the user. And then what we are trying to model here is basically the listing that we have here. So we ideally want the screen to look like this. Now, if you want to do the header, hey, more power to you. You're going to notice I'm not doing it, but I'm going to show you how easy it is to do. Yeah, I'm copying right from the example. I could very simply, and actually this would be before user input, is I would just do a print. You don't need to do printf on this because you're just putting text on the screen, and there it is. And then if you want a blank line to follow it, because that's what the example does, right? You just put in /n at the end, and that moves you down one line. Then here, we are going to start to prompt the user for input. And what it should say is the following. Please enter the total amount of the loan. So we have 3 prompts, right? And we should talk about how we're going to grab these, because remember, when you put a prompt on the screen and you just use the input command, it's only grabbing text. But we want to do math with what's input. So we need to use a conversion to change it into a number that's meaningful, that works for us. Now, whenever you're dealing with money or interest rates or decimal points, you always want to convert to a floating point integer. And then keeping in mind, we have all of these kind of givens up here in terms of how a mortgage calculation works. Now, I don't expect you guys to like be able to do a mathematical proof on this or anything. The biggest challenge really is just converting this into a regular formula, right? That's the hard part. But if it's helpful for you, and some people will do this, is they'll take all of this stuff and just paste it right into your code as comments, and then you can look at it on the same screen. So if you want to do that, feel free. You're going to notice I'm probably not going to do that. In fact, I might grab part of it, but not a big deal. The first part, right, is to get the following from the user: total amount of the user loan, the interest rate, and the length of the loan in years. So I'm going to do those 3 things, right? And here they come. And I'm copy pasting, and that's for the sake of speed here. So back over to Visual Studio Code. So here's the prompt for the principal, the total amount of the loan. So we have the input function, right? That's a regular input function, but an input function, remember, grabs text from the console. Just because someone types a number, it's not a number in computer memory, it's text. So then I have to put all of that inside of parentheses inside the float function, which then takes that text, converts it to a floating point number, and stores it in the variable. So the other thing, another takeaway from last week, the equal sign is not an equal sign, it's an assignment statement, right? Which means anything on the right side of the equal sign gets stored in the thing on the left side of the equal sign. We are assigning whatever this does to this variable, right? This is just terminology and kind of repeat to reinforce. Hopefully it helps. Next, we're going to grab the annual interest rate. So we want to ask the user what's the interest rate you're getting quoted. Same conversions. Text comes in, convert it to a floating point number, and store it in this variable here called annual interest rate. This is kind of verbose, but there's kind of this thing happening in programming right now where you're encouraged in modern programming to try to make your variable names as verbose as possible, so you're not later guessing what they are. In the old days, we might name that something like ANINTRT or something, and then you'd be like, what does that mean? Right? And if you didn't put a comment in that place to indicate what what that meant, you'd be guessing, but there's no guessing on what this is, right? Verbose variable names are very important. All right. Now, the user, and I want you to keep this in mind, is going to enter the interest rate in the way that makes sense in their mind, which is like, hey, what interest are you paying? And I think the example is maybe 5.5% or something like that. I don't know if that's close to accurate right now. It's been a long time since I've shopped for a mortgage. Um, but they might type like 5.5 or 5.75. But in reality, a percentage rate can only be between the value of 0 and 1. And so 5.5 would be 0.055, right? I have to take that into account when I do my calculations later. Some people will actually do a conversion, even right in this statement, or have a separate statement that converts it to the formula. I'm not going to handle it that way, and I'll show you where I handle it. That's coming up. The other prompt is to get the number of years of the loan. So this is pretty common too. Typically you buy a house, it's a 30-year loan. That's the most typical, but it's not unheard of to do a 10-year or 15 or a 40-year. I've heard of those these days too. And the number of years is relevant to how much interest you pay. So the longer the loan, the more interest you pay. The shorter the loan, the less interest you pay, right? The other thing that a lot of people are not aware of when they buy a house and get a loan for a house is that the beginning part of your mortgage is super interest heavy, right? So you're paying more interest than you are principal. And as you get towards the tail end of the loan, you end up paying more principal than interest. Why? Because it favors the bank, basically. The bank makes more money that way. And every time you refinance, the bank makes out even better because you go back to the beginning of the loan, which is interest heavy and very little principal. So I don't want to give you like life advice here, but I'm just saying. All right. The other part of this, and this is where maybe you might want to paste the stuff in. So this is kind of given in the example. I'm pasting it in and converting it into comments. Why? Well, it's kind of handy to remember what all the things mean. If this helps you, do it. If it doesn't, don't, right? But the equation will certainly help me. And you know what? It's not bad to have a guide to remind you of like what each thing is. What's unusual here, and this is maybe the biggest challenge of the assignment, is recognizing this represents an exponent. We can't really show it in monospaced fonts that this is actually should be a superscript. In other words, it should be smaller and raised up so it as an exponent. So n is an exponent here, n minus 1 is an exponent here, right? What characters do you change to convert an exponent in Python? You'd use 2 asterisks in a row. The other piece that apparently a few of you missed as well is when we do regular mathematical notation, we know that when there's like a variable or a value in front of parentheses, that implies multiplication. But guess what? In Python, that's not the case, right? We have to put in a multiply sign like right here and right here. Otherwise, this equation will not work, right? That's probably the biggest challenge of the whole thing, right? This is our reference. Let's keep coding here. So the next thing that we want to do is we want to determine basically what R is. And this is kind of weird because you're going to say, well, hold on a second. We already got the interest rate, right? Well, yeah, we did in terms of what normal humans would refer to it as. Like, for example, I think, I was using 5.5 as an example, right? But mathematically, we need to adjust it so it converts to the right number format. So we're going to take the annual interest rate and paste it in here. And then we're going to divide by 12. And then we also need to convert it to the right format numerically, which means we really need to divide by 100 again. But if you do that twice, what ends up happening is you're really dividing by 1200. So what this does is it converts it to what the monthly interest rate is, because that's how often the interest rate compounds, and puts it into the correct numerical format, moving the decimal place over. You guys may have handled this differently in your calculations, but this is how I chose to do it, right? So this one's maybe a little bit of a leap. If you read the instruction on this, right? Um, and maybe I have a little comment that I'm going to paste in over here. Maybe this comment would help you for this one, which would be divide by 12 months and then divide by 100 for percentage. And that corrects it. So then the rate becomes here 0.055, for example. Next, we need to calculate N, the number of payments monthly based on the years that are input. So the way that we'll do that formula is like this. So we'll calculate N, take the years and multiply by 12. So how many payments are you making? Like, for example, like if you guys buy a car, right? Like you might get a 3-year, 4-year, 5-year loan. And then usually it's like, how many months is the loan? And it's like, oh, I guess I got to multiply by 12. Right. So we're taking the number of years of the loan, maybe 30, and then multiplying by 12 to get the total number of payments. So we have the total number of compounding periods, therefore. Hopefully that makes sense. All right. Next, we're going to calculate the monthly payment. And I'm just going to take that formula again, and I'm going to paste it into a comment like so. Right. Just pulling it down basically. So really, I mean, if you want, like I said, you don't need this stuff. I think it's just helpful to look at so you don't have to bounce back and forth. But this is the formula we're converting. And I hope it resonated with you last time when we talked that if math puts you into a panic, because it does for a lot of people really freak out, right? What I always tell coders is like, hey, you don't have to be a math whiz. You just have to know how to convert that formula to whatever language you're working on, right? And this is no exception. This is actually a very good example of that. So when we calculate out that monthly payment, it will end up looking like this. Oops, sorry, wrong paste. All right, sorry about that. You ever feel like you have too many windows open? It's kind of my situation right now. All right, there you go. So there's the equation converted. And I want you to notice here that principal that relates to the P. Notice the inclusion of the asterisk to multiply. In math, we don't do that. We just say it like this. In Python, we must add the multiplication symbol. Otherwise, it won't. Just won't do it. Here, okay, if you're wondering why, here's the why. Whenever we use parentheses in Python, it's because usually we're running a function, and we're going to learn about functions today. And usually if you put parentheses after something, it means it's a function and you're sending it some information. You're not multiplying. That's the why. It works that way. Same thing happens here with the R. Here it's implied. Here it must be expressed. And then the exponent notation here also is converted to the double asterisk. Otherwise, everything else really kind of falls into place. Exponents, multiply. Those are the hard pieces to convert. Now, the equation is done. Then really all you have to do is output the results. And kind of like we did, I think, in the final lab, we use the F-string approach to do this. And, so basically we're inserting the variable here. The $sign is just text, but we're also adding the formatting command of .2f, which rounds to 2 floating point spots. Why? Because that's how money works, right? We don't go to hundredths of the penny unless we're buying gasoline, I guess. Otherwise, we round everything to the nearest penny. That's pretty standard financial format. Now, if you omitted that little piece at the end, I would still accept it as correct. If you didn't format it as money, as long as you had the right answer and you realized that you'd have to, round to the correct penny. And so, what, let's go ahead and run this. And we're going to use the values from the example here. So 300, 5%, 30 years, and hopefully it comes up with that same number, right? That would be kind of the test that it's working correctly. All right, so I'm going to scroll the code up a little bit. I'm going to hit the run on this. I'm going to click into the terminal so my prompt is active, and I will enter 300,000. Notice no comma here, by the way, right? Press enter, enter the interest rate. We're going to 5% is what we're doing. We're doing a 30-year loan, very typical. And there you go with the payment. Does that match up? It does precisely, doesn't it? Right, 161046. And any mortgage calculator you would use online. There's lots of them out there, by the way. Should give you the exact same result if you're using the exact same values. Another way you could write this program, and I'm just putting it out there, you could skip this weird, conversion here where we're adding, or, truly it's actually multiplying by 100, not dividing by 100. So Dresden, thank you for putting that in the chat, by the way. That is the correct calculation. So if you wanted to omit that piece, you could have your user enter the interest rate as 0.05. Why don't we do that? Because most people aren't clever enough or remember that, right? Because we speak it as 5, so we want to enter it as 5. And intelligent programmers will often, maybe even just, like when they're prompting the user for that information, might even say, example given, 3% equals 0.03, for example. Right? And that's the way I would code it if I was really doing a professional program. It's good to give examples if you're expecting good data so that, you do the correct calculations. Now, hopefully this worked for you. What I'm going to do now is I'm going to terminate this recording. So those are the solutions, and the recording will end here, but I'm willing to look at and field any questions relative